And I've hacked over everything on here.
Security training there.
Yeah, right. I know. I'm like, oh no.
Yeah. I'm glad we had a great transition. I'm afraid of putting it on the network of what anyone might send me.
You know what? No, yours is plugged in now.
Okay.
Okay.
All right, let's go. Did I say that loud enough? I need people in the room. Take your seats. We got to get going here. All right, come on, Matt. Let's go. We're going to get started. Sit your butts down. Yeah, that's what Mandy said. I'm just paraphrasing. Come on, Corey. Jimmy G. Take a seat. He just waves. Okay, you know what? I'll share something funny. I'll share something funny while we're waiting for people to get into the seats. We're going to start here in 2 minutes. You know how I introduced the board? And I said something about Paul McMillan, who takes care of the sponsorships. And I said he's down in Florida with Mickey Mouse and the kids or whatever. I was kidding. I think he went to like Colorado or something. He's actually watching with his kids. So now his kids think they're going to Disney. You want me to tell a joke? Mountains aren't funny. They are hilarious.
See the top paragraph.
That is literally the thing that was called in on iPhone.
Test. Have you guys heard about the latest pirate movie coming out? It's rated R. Now that's a bad dad joke.
All right, we're going to get started. Please close the back doors. And I'm going to go out in the hall and wrangle some other people up. But Greg, you're up.
All right, thank you guys. Pleasure to see everybody in person after a year and a half for me or so, since the last time I got to speak somewhere. So my name is Greg Levenhagen. I'm here to talk about AI in the practical business sense. How do we get it into our companies? What does it look like? Where's that starting place? So to start, we have to kind of address some of the buzzwords and phrases that are in the room. So we've got things like AI for artificial intelligence, ML for machine learning, data science, relatively newer term over, say, the last 5 years, and then computer science. Data science didn't exist as a degree that you could get more than like 5 years ago. Computer science has existed for decades. It's important to realize that up until about 2012, most of the algorithms and data science, or what we now call data science and artificial intelligence, just fell under computer science, and it still technically does. It's all just a branch of computer science. And so we've had people doing this kind of stuff for a long, long time. I've had the chance to interview about 24 people, whether I've worked directly with them or reached out to them in a professional or technical community capacity, to say, what makes you a data scientist in your role? A lot of them, the majority of them, end up having a PhD in economics or statistics. We're going to talk a little bit about What's the need for that? Why is that educational background important? What are the other educational backgrounds, and how does that team structure kind of come to life? Machine learning is really a subset of AI. So you will often see AI or ML used interchangeably or even with a slash. Machine learning is a subset of artificial intelligence. So when we look at this diagram, I have high level types because there are lots and lots and lots more of types that these break down into. But when you're considering things for your business, I have a new clicker here, so I want to make sure okay, I got a pointer. So machine learning is one of those branches. Now, machine learning can be done in whole oodles of ways, supervised, unsupervised. It can be based off of image stuff. It can be based off alphanumerical data, all different scenarios that your company may or may not have a need for. We also see things like speech and vision. Speech, pretty typical case. We can look at things like Alexa and Cortana and Google Play, those kind of things. We've started making our way into our day-to-day lives. With natural language processing, does anyone remember the web browser called Ask Jeeves? The web search engine Ask Jeeves? Oh, yeah. Right, so Ask Jeeves was an attempt at natural language processing. NLP has been around for decades and decades in the field under computer science, under AI, but we're hearing about it now primarily because of a couple reasons. We have enough data. We also have enough processing power with various cloud technologies. Before then, it just wasn't practical. Expert systems, planning and optimization and robotics are all interesting. So robotics is kind of automation thing. We can see that a lot in our state with manufacturing being about a third of our economy. Planning, optimization, right, it's pretty much what it says it is by definition. I don't know if I need to dive into that. Expert systems, though, try to make decisions based off rule engines or something else. So something that's been used in heavily for decades already is medicine. That doctors can input certain types of symptoms, and expert systems will help them try and predict what those systems are for diagnosis. So it's important to realize that if you're a business that's looking to do this for your product, your deliverables, your consumers, or you're a consulting company and you're trying to offer this as a solution, or you're trying to make a new solution like a software as a service, it's hard to go at all of these at once. So you kind of need to start to see where's our primary benefit, where's our biggest gain going to be. So I want to move into dynamics, back a little bit about team makeup here. So this is from a website called Towards Data Science. I somewhat agree with it, enough to show it here. Now, I've been leading my company's AI practice for about 3 years now, and what that is. And I'm somebody who's classically educated in AI. So when it comes down to this, we see the green is computer science. Hopefully those colors are showing up good enough for everybody. Can you see them? So the top right, the green, is based off saying computer science. We have our Venn diagram where the magenta is the top left circle, and then mathematics is the bottom left. As somebody who's taken computer science, I took a heck of a lot of math. Did anyone else take a lot of math for a computer science degree in the room? I mean, so you failed a lot, Randy, okay. So the overlap here is pretty interesting. So they call out the mathematics specifics as finance department and econ. So they're really kind of trying to hone in at the statistics and the economics, not so much the 7 classes that I took after Calculus 3, right? Now, if you have people in your work that have the mathematical background like I do, they're certainly capable of doing the economics and the statistics that they would from an MBA in that kind of stress as well. it's important to realize that because these things mix and match. Now in the green area, the only sole thing that they have in there is DevOps. Well, I know from firsthand knowledge working on over half a dozen AI projects in the last couple of years, it's not only DevOps. There's a lot of software development that's needed in order to actually operationalize or productionize, to make up a word that's often used in this space, the AI. Because going from an R&D phase and getting it from the data scientist in that R&D phase and actually making it consumable for your customers or your business to make a difference on decision making is no small step. It's actually what I predict over the next 10 years to be the biggest amount of growth in this area. I don't anticipate huge amounts of growth in the data science role. I just don't see the need, and we'll see why, I'll argue as to why. I don't see the need for us having millions of data scientists with that PhD level. Now on the top left side, we see sales and marketing, business analysis, and that's really what they're referring to as domain expertise. This is crucial. Somebody who knows all of the AI algorithms and somebody who can code up everything else. If they don't understand what your business is trying to solve, it doesn't matter. Now, as a leader in a technology consulting firm, I can't tell you how many times we get clients that want to come to us, potential clients, and say, I want to have an AI solution by the end of the year. Or, I've got a problem here, Greg, this is a great case for AI. And then after I do some initial investigation and digging into it, it's not AI. We can solve it with easier mechanisms. A lot of that has to do with the buzzword, the curve of innovation, and where AI is on all of that, as well as some of the tools that are offered in the big three cloud providers, et cetera, et cetera. But that data scientist, architect sits in the middle. The key part that I want to point out here is this ML engineer. I think this ML engineer is going to become a massively expanding role in both terms of the quantity of them within our industry, as well as what their expectations are, their role is to do. I would argue we already have plenty of data engineers. Those are the people that are used to doing extraction, translation against existing databases and doing business intelligence and reporting kind of stuff, right? Where there's a little bit of a mix to the business analyst, where those business analysts will also be called like data analyst, right? Whether they're doing Tableau or Power BI, surfacing that data for the consumption. Yes? That the domain experts are the design engineers? Yeah, so I'm not going to disagree with that. Like I said, this is loose. The domain expert, right, where the business analyst is in the magenta, the sales and marketing is, it's because they're going to understand that. So as far as designing a product or a need, that would make sense to have design engineers in that area because they're going to know the true business need. They're not going to be specialized in math and computer science to achieve that goal that is set forth by the team in the magenta piece. Yes. So I've come up with, in talks, small and large over the years, a four-path hierarchy here, and also a four-step growth pattern that we'll get to for data later. But for consumption models, I'll first draw your attention to the green arrows pointing down. So 1, 2, 3, 4. Now I've got some examples of the logos here on the left and right sides to correspond to each level. I happen to think Microsoft has the best comprehensive suite of these type of tools. I regularly stay up to date on AWS and Google Cloud Provider services, whatever they're calling it now. But at the top level, we see the least difficult. It gets more and more difficult as it goes down. When you're evaluating things for a business, you want to make sure that you're starting at this top level. If you can achieve it with that, it is going to be the least cost, lowest cost for you to implement, as well as maintain with an asterisk with the maintain. But for the long run, I would imagine so. So in no code, low code, everyone's heard of that phrase by now, right? In the last couple of years. So Microsoft has that thing in Power Apps called AI Builder, where it's really a user interface. You drag and drop some things. They also have like a bot builder that can do that. These are really nice tools. They're only going to get you so far, though. And so when you hit that limit, that limitation, you get into what are exposed through APIs. Those APIs, the key phrase, if there's one thing you really take out of here, although it's not what I would consider the most important, but for you as business leaders and decision makers, the developerization of AI, it's a made-up word. I'm using it as a play off consumerization. If you walk away realizing that, you don't need to have AI people, specialists in 3 and 4. You can take your .NET or your Java dev and your Python dev, and they can start calling these existing APIs, just like they would call an API for some other product you wanted integrated with, like your ERP. They can do that. They can pass an image. They can pass a record of data for, I want to predict my travel route. Is this optimal or whatever? Right? They can call into those kind of things, and Microsoft's providing a whole bunch of them. That is a key piece. That's one of the reasons we're seeing more and more of this growth. Of course, there's some great R&D research that's driving that under the covers, but the third one here is where we really get into the data scientist, the true machine learning engineer, where they're talking about taking, you've got 4 terabytes of your product's images and your competitors' images, and you want to identify them on the spot with a mobile phone, and you want to be able to predict the price and the replacement of those, and you want that to be lickety split and then go over to your e-commerce store and have them just hit the buy now button, and you've just won a competitive situation. You want that whole kind of thing to play out nice and smooth, fully customized. You're probably going to use what's called Azure ML in that case, and that can host all these open source frameworks. They all support open source frameworks. There's no real lock-in on any of that. And then there's 4. Who should be doing 4? Anyone in this room? Yeah, unless you're like studying for your PhD at Marquette or Madison or Milwaukee, no, you really shouldn't. Right? I know we have a great NVIDIA lab going up and stuff, and so I would love to get in there and do some R&D. But as far as like a business scenario, that's left for the PhDs at Google and Microsoft, right? Like that's not practical for a normal business to be getting into. So how can AI augment businesses? I want to run through a couple examples. These are real world examples. I can't quote them as far as the actual companies because I haven't got permissions, and it's for one reason or another. It's not that they're against it. It's more of like legal, contractual kind of stuff. So one of them I already alluded to in that situation of having competitor parts. If you think about that, if you have any kind of system, like say an automobile, and you're a car part maker, and you want to replace that stuff, one that is not a client, I'll call them out just because everybody knows their name, Milwaukee Tool, right? People could take pictures of competitors' tools, and Milwaukee Tool could then come out and say, hey, here's a equivalent part of ours. And by the way, we'll give you a 10% discount because you used our app here and you're a new customer. Right? Like those kind of leads are lowering that cost for a new acquisition in a sale, right? There's also the kind where it can augment business in terms of human capital in high, high danger situations. So for about a year, I've been working with a client on a drone-based system where we're taking images and video, and you can do it both in real time or back on the server, but we can detect anomalies and changes and do predictive models or determine when there's a mistake happening. And what that does is, let's use the 80-20 rule. Let's say 80% of the time, it can, instead of detecting the anomaly, it's actually flipped around. It can verify that it's okay. It's actually a lot of times easier to verify that a system is okay visually than it is on the anomaly. So now we've got a place where we're only sending people up in hazardous high-rise situations or climbing up poles or using expensive, dangerous equipment in 20% because they have to go through an inspection on that device or item rather than doing it at 100%. So now they can cover more ground in less time. That's a big thing. You're not having to pay high-risk stuff. You don't have people getting injured on the job place. You're getting turnaround results, reporting, predicting mean time to failure. All of these kind of asset critical type of measurements can help out. Another one that we worked on was optimizing routes. This one I bring up because I want to mention AI is essentially non-deterministic. It's a multi-syllable word if there ever was one. When you guys have your software developers or you're creating some software, if you say, I want the user to click a button and that button should do X, that's deterministic. It should do that over and over and over repeatedly, same input, same output. The problem with the computer science sub-branch of AI is that it's really not deterministic. It's heuristical based or confidence based. So when you evaluate a record for a trucking route and they're going from Green Bay to Tallahassee, and they're looking at weather conditions, fuel prices throughout different states, different routing paths because they're carrying hazardous material, so there's 4 different ways to get through southern Illinois. Like all of these kind of things. It's predictive, it's suggestive, it's confidence-based. It's never going to come at you and say 100%. If anyone working in AI tells you 100% confidence, fire them. Okay? So you have to first realize that there's a comfort level that I've had to walk through with some business decision makers that are in control of the budget, because what I just explained to you means you can pay a couple $100,000 for a solution, and at the end of the solution, not have a product that has high enough confidence for what your business needs. How many people think that's a little scary? It can be. It can be. But what we found, like in the case of this transportation thing, we say, okay, how about you do a baseline? Try and figure out some metrics of what your human performance is right now, or your current non-AI technology is now. And so it was about 20%. They got above 70% with only 6 weeks of R&D. So 6 weeks of R&D got them a 50+% improvement in calculating their route efficiency. How much did that make in terms of an annual savings? Tens of millions annually. I'd like to go to my boss and say that. Hey, check out this, right? So that's one of the challenges in understanding that, is that heuristical nature. I already mentioned one of the things about I looked at the time and lost my train of thought, sorry. So the challenges here, we look at communication with the business and understanding confidence. We look at another challenge of bad data. One of the things I can tell you as an immediate action item, versus opposed to before I said remember something, an action item right now for you to do, save all the data. Start saving everything now, so that in 2 or 3 years, when you're ready to make a decision, or you finally say, I've got money, or I figured out some use case. If you don't have the data, you're going to be twiddling your fingers. So we run into that, and that lowers the confidence score, which then makes the risk go up for the business, and that's posing a big challenge. Now, there's several other challenges. When I look at data maturity, this is another thing that I've come up with kind of over the years, and I kind of qualified in 4 stages. And I say normally a business starts out and they buy some off-the-shelf software, maybe for accounting like Quicken. Maybe they use Access or Excel to do some other things. Those start generating some data. Maybe you're just using Excel spreadsheets to run your whole business for the first 5 years. That happens all the time. But that's generating data. At some point, most businesses go on to phase 2, where they have growth. Growth usually means that they're going into bigger systems that start producing even more data, and or buying custom software solutions that help set their specific business needs as a unique driver to get them ahead, right, of competition. So think of that as they've got some custom software, and that's generating a lot more data now. Stage 3, I loosely will put as business intelligence. Business intelligence, data warehousing, data mining, data analytics, those kind of all fit at this stage 3. A lot of companies have been trying to get there for the past 10 to 15 years. It's been a lot of the buzz, teams, expertise, those data engineers, those reporting engineers, big deal, right? They help drive decisions for the business. A lot of companies, though, are sitting in between these 2 stages. You don't, there's one caveat, you don't have to go from growth to BI to AI. You can kind of circumvent BI, but what you end up doing is once the AI starts producing enough information that's useful, you kind of circle back to the BI piece because the executives and the decision makers are going to want to have that reporting piece so that they understand what the AI is doing more and more. But this growth model is pretty interesting. If you're not doing any BI or AI right now, just start saving all your data. Make sure it's not going anywhere in that growth stage. It will make your life easier. The last thing that I wanted to mention here is a little bit about how the team structure works. So what I've found is that for every kind of data scientist that you may need to bring in, and you may not actually need to bring him or her in, you'll need 1 or 2 machine learning engineers. And when I say machine learning engineer, like machine learning software engineer, it shouldn't be too much of a surprise for you if you've worked in embedded stuff or mobile stuff. You realize like you're hiring mobile software engineers or embedded software engineers or whatever it may be, front-end web stack software engineers, right? Machine learning software engineers, they have the same core skill set. They've just added on some additional knowledge in terms of how to operationalize machine learning. And algorithms, correct. Now, below that is in terms of the numbers, not in terms of talent or whatever, is the data engineer and that business analyst, where you may need 4 or 5 people doing data ingestion, bringing it into the system, ingress, egress kind of stuff, moving that data around, just to make those people that are making a higher level salary in the machine learning engineer and the data scientist so that they're efficient. It's funny when I've consulted with and talked to like Microsoft and some other big AI type firms directly, and they will sometimes think, well, why don't these companies have a team of data scientists? And I'm like, yeah, unless you're a Fortune 100 company, unless you're JCI down the street, like that's not happening, right? It's just not, right? They're going to go out to a data science consulting firm and make sure that they're scrutinizing the use of them because they're charging $250 or $300 an hour. That's nothing to sneeze at, right? So it's interesting on that play and those dynamics. So I mentioned that because AutoML is something that I know Google and Microsoft are working on heavily. They're both doing great at it. AutoML, auto machine learning. You're like, okay, is that the machine teaching itself, learn how to teach itself? Yeah, kinda. It's a little meta, right? So what's happening here in the case of computer vision, I think it's easier to do in a visual context for an example. If I've got 1,000 pictures and they all have different birds in them, the easiest thing to do with images is what we call classification. It will try and classify the entire image. Is there a bird in there or not? Well, Microsoft and their researchers and Google and their researchers know there are, say, several dozen of these type of algorithms that are good at solving object or image classification. So they will take those, they'll take your 1,000 images and you give them the 1,000 images, and you'll say, I think there might be a bird, maybe a cardinals and blue jays I'm interested in. And it will go and run them against the right algorithms that they think are appropriate in their cloud on these high-end GPUs, and it'll run for an hour. You pay for 1 hour resources, and that's it, and it'll come back and it'll say, here's the top 3 performing algorithms. Go nuts with those. Have fun. That's great. I just pretty much eliminated the need for a month or two of a data scientist doing that. As a machine learning engineer, I can say, hey, go take those 3 and that data set and fine tweak it. You don't have to have all of that background knowledge on it. Microsoft kind of did that for us, or Google did that a little bit for us. I see some smiles in the room. Some people are very skeptical on this. Some people are very bullish on this. I tend to be a little bit more in the middle. I'm a very much use the best tool for the job kind of person. I have seen this get accurate, and I've seen it become wildly inaccurate at times. The one thing I can bet money on, though, is that Microsoft and Google are going to keep investing in this, and I think it will only get better and better. So watch out for AutoML and how it can jumpstart your business in terms of getting started with AI. So I am out of time. Thank you. Any questions?
What do you think?
I know we're supposed to switch over to
yeah.
right away, but
Yeah,
while they're coming up.
Let's see if are there any questions out there? We have time for 1 or 2 questions. Come on now, don't be shy. Tim did it to me. Don't make me call on you, Paul.
Well, feel free to reach out to me. You can find my LinkedIn address there. I'm happy to chat on there, and or my Twitter is just my name. So,
Greg, thank you very much.
yeah, thank you. It was a pleasure.
All right, and we're going to flip over to Katie Herman and Dustin Shimmick right away, so don't go away.
So I've got a little anecdote where they're getting ready to switch. So this morning, I get called up from Quicken Loans. Now, I happen to be in the market for refinancing, so I take the call. And it's this young buck, he's probably 23 or whatever, and he proceeds to tell me, he goes, you're the first person I've talked to in my job. And I said, what? He goes, everyone that it calls, I get voicemail. So you're the first person, and you seem cool. And I'm like, okay, let's go with this. And, you know, he's just really energetic. And I'm sitting there thinking, okay, what's going to go on? Am I going to have to, like, give him all kinds of banking info? He's like, no, I'm not that guy. I'll hook you up with a banking guy. But instead of putting you on hold, let's just chat because you're the first person I've got to talk to at work. So he asked me about Wisconsin cheese because he knew I was in Wisconsin. I'm like, well, where are you from? He goes, well, Michigan. And I said, Michigan, it's a great state, been there many times. I said, do you know what people in Upper Michigan call people in Lower Michigan? And he goes, Yoopers. And I said, no. Yoopers are what you call people in Upper Michigan. People that live in Upper Michigan call people that live in Lower Michigan trolls because they live below the Mackinac Bridge. Thank you all.